Hello, in this video I'm going to talk about parallel and perpendicular lines. We'll start off by talking about parallel lines. When two lines are parallel, they have the same slope but different y-intercepts. So for instance, I've drawn a red line and a pink line here, and I've shown what their equations are. You can see they have the same slope, both 1 over 2, and they have different y-intercepts, 1 and -2. So if we want to know the equation represented by a line that passes through 6, 4 and is also parallel to the graph of y equals 1/3 x minus 2, first of all, what we know is that the slope of the new line is going to be the same as the slope of the previous line, so we know 1/3 is going to be the slope. And now we also know that the line is going to pass through a point 6, 4. So to figure out the equation that represents a line that has these attributes, we just need to use point-slope form. Point and slope. So point-slope form, if you don't remember, is y minus y1 equals m times x minus x1. And so we just plug in the y1 and the x1 and the m. So it's going to be y minus 4 equals m, which is 1/3, times quantity x minus x1, which is 6. And that's the equation of the line in point-slope form, but they want it in slope-intercept form. Remember, slope-intercept form is, let me write that down, slope-intercept form is y equals mx plus b, so that just means we need to solve this for y. So we get y minus 4 equals 1/3 x minus 2, because 1/3 times 6 is 2, and then add 4 to both sides. So we're going to end up with y equals 1/3 x plus 2. And so it passes through 6, 4 and is also parallel to this because it has the same slope. Now I'm going to talk about perpendicular lines. Perpendicular lines will have slopes that are opposite reciprocals of each other. So I've drawn two lines here that are perpendicular, which means they meet at a 90-degree angle. The slope of the red line is 2/3, and the slope of the pink line has to be opposite, so it has to be negative, and it has to be the reciprocal, so 3 over 2. So negative 3 over 2. So here's a question. Are the graphs of 4y equals negative 5x plus 12 and y equals 4/5 x minus 8 parallel, perpendicular, or neither? The only thing we need to know to figure this out is their slopes. So to figure out the slope of this line, we should probably put it in slope-intercept form. So here's the original equation that we're given. And to get it in slope-intercept form, I'm going to divide everything by 4, not just the x term, but everything. So I'm going to end up with y equals negative 5/4 x plus 3. So the slope of this line is negative 5/4. The slope of this line here is given, because it's already in slope-intercept form, as 4/5. Their slopes are opposite and reciprocal, so they are perpendicular lines. So if I need to know what the equation of a line that passes through this point and is perpendicular to this line, first I need to know that the slope of this line is given as 2, because this is in slope-intercept form. A line perpendicular to that is going to have a slope of the opposite reciprocal, so we need that slope and we need this point. And so we can use point-slope form, which we just used earlier, plugging in y1, m, and x1. So we're going to have y minus 5 equals negative 1/2 times x minus 3. and we're going to solve for y. Let's see. So we'll have y minus, whoops, what did I just do there? Let's put that back. Okay, so we're going to have y minus 5 equals negative 1/2 x, and then a negative times a negative is positive, so plus 3 over 2. Now we're going to add 5 to both sides. Y equals negative 1/2 x plus 3 over 2 is 1/2. So when you add 5 to that, we get 6/2. And that's it. Just to double check, the slopes are opposite and reciprocal, so we're good to go. And one more example here. An architect uses software to design the ceiling of a room. The architect needs to enter an equation that represents a new beam. The new beam will be perpendicular to the existing beam, which is represented by the red line here. The new beam will pass through the corner represented by the blue point here. What is an equation that represents the new beam? Okay, well, we need it to be perpendicular, and we need it to pass through or touch the blue point. Okay, so first of all, we need to figure out the slope of this existing beam. So the current beam has a slope of, it looks like it's going down, I don't think it's 1 exactly, so maybe down, well, to be sure, we're at 8 and 12, so it goes down 8 and right 12, so that's negative 8/12, which would reduce to negative 2/3. And so we need a slope that is going to be positive 3 over 2. So here's what our new slope needs to be. And we know that our new line has to go through point 12, 10. And so with these two pieces of information, we are good to go. We just need to use point slope form like we've done in the previous two examples. So we're going to say y minus 10 is equal to 3 over 2 times x minus 12. And now solve for y. So y, let's do y minus 10 is equal to 3 over 2x minus 18. We'll add 10 to both sides, and we get 3 over 2x minus 8. So we know the slope is good because it's the opposite and reciprocal, and we know it passes through this point, and so we're good. We have this new beam. We could draw it if we wanted, although it might be difficult because it would start down here at negative 8. But if the slope is going to be 3 over 2, that means up 3, right 2, or down 3, left 2. So let's draw it here. Down 3, left 2. So something like that. And that looks perpendicular. Thanks for watching.